Hi, we are Particle3D, and we have one question. Why harvest bone when you can print it? So, there are more than 2 million bone grafts harvested from patients each year. And for those of you who are not familiar with the term harvested bone, is when you need, for example, a facial reconstruction, the surgeon will take and cut out a piece of bone from your hip or your leg and use it as an implant. This is both time-consuming and it aids to complication rates. The alternative is to use foreign materials such as metals or plastics, but these are often off the shelves, one-size-fits-all implants. In short, the surgeon has only few available options that are either foreign materials harvested from the patient, and all of these often lead to poor aesthetic and anatomical outcomes. So, at Particle3D, we print bone. Our technology allows us to make a patient-fitted, porous, and degradable implant. This is better for the patient. It is better aesthetic. It is better functional. It has fewer complications. And it's better for the healthcare professional. It shortens surgery and reduces costs. It's better for the healthcare system because you have a faster turnover on the operation room, and you have fewer costly resurgeries. Our mission is to provide patient-fitted, mission is to provide 3D printed natural bone implants that will reduce complications, improve functions, functional and aesthetic outcomes, and aid to a faster recovery. Our vision is to become the major player within the tailor-made bone implant field. The team consists of our CTO, Thea, then we have CEO, and we have Martin, our CTO, and then there's me. We also have Julie as our chairman and an independent board. And we have advisors as well. If you would like to hear more about us, the management team is here for the next days. When we look at the market, as mentioned, there are 2 million bone graft procedures globally each year with an estimated of 2.4 billion. Furthermore, there's a cosmetic surgery of bone implants in the facial area, and that is estimated to $1.2 billion. Our target market is the cranial and maxillofacial. That is the face, mouth, and jaw. And we are primarily focusing on the US first. There are several reasons for this. First of all, US is the largest market, and at the moment they have a more feasible access to the market due to regulatory affairs. When we take a comparison of the market players, none of them can offer what Particle3D can offer. They are either foreign materials or not patient-fitted at all. Our sales model is divided up where the patient will be CT scanned at the hospital. The surgeon will then model the implant, accept the design, send it to Particle3D, who will print it, sterilize it, and ship it to the hospital or clinic, and the surgery can commence. We have done several proof of concept studies. We started out in mice. Then we moved on to larger animals. So we did a pilot study on 6 pigs for 8 weeks. Then we scaled up to our largest study yet that involved 8 pigs for half a year. And what we see in all the trials is that not only does our implant fuse together with the native tissue, it also develops new bone, bone marrow, and blood vessels within the tissue, which means giving time, the implant will degrade and become a natural part of the bone, of the patient's bone. So, Particle3D is built upon a patent that was written back in 2015. In short, it is just combining a fatty acid with any kind of powder and extruding it out of a nozzle. Now here we are using tricalcium phosphate combined with a fatty acid to print bone. But our patent actually allows us to do so much more with, for example, other industries. We have devised a 3-foil strategy where the first leaf is our patient-fitted bone implants. Then we have our next type of bone implants. This is with additives. So by combining the fatty acid with pharmaceuticals such as antibiotics, chemotherapy, or growth factors, we can actually have a very controlled, slow release from these bone implants. Our third leaf is P3D models. This is primarily scaffolds for research, so cell studies, tumor research, or drug development, but also educational purposes for CT scans or surgical preparation. And then there's the stem of the 3-leaf foil. This is our IP. As I mentioned, the IP allows to print so much more than just bone implants for other industries. And here we intend to license out the IP to other industries. This could, for example, be the space industry, which is very keen on 3D printed ceramics. We have our main core business. This is our implants, our patient-fitted 3D printed implants. But we see there's probably a higher value for the drug-releasing implants, but also a longer time to market. So what we intend to do is we want to collaborate with big pharma companies to push these out in collaboration and not take it upon ourselves. Then we have our 3D models. They will not hold the great value on the market, but it will make awareness about the company. And we have our licenses. And the licenses depend on what kind of companies we can license the technology out to and what contracts we will make. So, Particle3D is actually now looking for the next round of funding. We are expected to raise $3 billion, and it will push for the GLP study, the regulatory process, and the research in the drug releasing implants and growing the organization. So thank you very much.